Here is problem number 15 on page 61. Here's how it reads. Parentheses, xy minus y squared times dx minus x squared dy equals to 0. And then there's the initial condition, y at 1 equals to 1. So initial condition problem. Well, as we found out, we have a choice of what we let u equal to. We could let u equal to y over x, or u equal to x over y. And does it matter? In my opinion, it doesn't matter. I don't think it does. Now, it may, change the integration slightly, or a little bit, but I don't know. Well, let's see here. It is, by the way, what order? It's order 2, because this is second order. That term's second order. That term's second order. So there we go. I guess I'll go back and use this substitution. First, I want to look at the book answer. Actually, I think I'm cheating, of course, looking at the book answer. I think they might have used this substitution, and off the top of my head, I can't explain why. But tell you what, I'm going to use this substitution, and we'll see if we can get the book answer from that. All right, so let u equal to y over x, and we'll go from there. So let u equal to y over x, which means that y would equal to u times x. And again, we've got to take the differential, so we can substitute in this case for dy. dy would equal to u dx plus x du. So let's feed everything into it that we know, and we have x times y. Now y is u times x, so it's x times ux squared, minus y squared will be u squared x squared, and then we have dx minus x squared times dy, this mess, which is u dx plus x du. All that equals to 0. Alright, so what can we do here? We can factor out x squared here. X squared is already factored out, so let's divide everything by x squared. Okay. And I just noticed that the initial condition was y equals to 1 when x equals to 1. Notice they didn't have x equals to 0, because I would be dividing by 0, wouldn't I? Food for thought. Alright, so we divide by x squared. The x squared is canceled here, so I have u minus u squared, parentheses, dx, minus, and this x squared cancels. Let me show those cancellations. There we go. So I've got minus u dx and minus x du equals to 0. So, do we have anything else we can do? Well, look here. I have u dx minus u dx. These cancel. Actually, that cancels as 0, doesn't it? It cancels entirely as 0. And so this term, u dx, cancels that term, which gives me minus u squared dx minus x du equals to 0. Alright, well, I'm going to transfer one of these to the right side. So I'll just arbitrarily take that one to the right side. I'm going to do some erasing. So we have taken this term to the right side, minus u squared dx equals to x du. Go ahead and erase this. Well, let me see, we'll separate the variables. So I'm going to divide by x, divide by u squared, and I'm going to divide by negative u squared. I think I'd like to have that negative on the right side. You'll see why in a second here. So I've got dx over x equals to negative du over u squared. Alright. The variables are separated, which means we can integrate. The right side is the same as integrating minus u to the negative 2 du. So left side I've got a logarithm of x, natural log of x, absolute value, equals to, I believe this is going to be u to the minus 1. Yeah, because if I take this derivative, I got negative u to the negative 2, which is exactly this, plus a constant. And what is u to the minus 1? Well, since u is equal to y or x, then u to the minus 1 is going to be the reciprocal. U to the negative 1 would be x over y, wouldn't it? So I can replace that. I've got natural log of x, absolute value, is equal to x over y plus a constant. Well, now let's see what to do. We can solve for our constant by plugging in our initial conditions. So when x equals to 1, then this equals to 1 over 1 plus c, and natural log of 1 is 0. 0 equals to 1 plus c. So that tells us what? It tells us that our additive constant is equal to negative 1. C equals negative 1. Alright, so my board is getting a little messy, but I think we're close to writing the answer here. Let me make room for it. So I have, let me rewrite it with the c. Natural log absolute value of x equals to x over y, and then minus 1. And let's get rid of the logarithm. Put it to the e power, so this cancels here. So x equals to e to the x over y minus 1. Alright, so I think that's probably the answer. Yep, that's it. We got the right answer. And there you go. So these problems with homogeneous coefficients are separable equations with the right substitution. It's a little tedious. You got some algebra to plow through, a little bit of calculus to plow through. But anyway, it's an interesting technique for turning a certain type of differential equation into a separable differential equation. So, all right, well, we're done with that lesson, that topic, and time for a new one.